Good morning, one and all. My name is Nagaraju Kakati, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Today, I am going to explain about the VHF, UHF, and microwave antennas. One, yes, in this region, we have the four different type of antennas we are going to study in our syllabus. The first name of antenna is Aguda antenna. Second one is folded dipole antenna. Third is helical antenna, and fourth one is horn antenna. Okay, so these antennas are named after one particular principle or the reason. The first name of Aguda antenna is named after two scientists. One is Aggie, second one is Uda. Actually, thing is that Uda invented the antenna and he explains that entire explanation in the Japanese. Okay, later the translated into the English by this Uda. So because of his translation, this antenna got the huge publicity and as very familiar as Aggie's antenna. But to honor the invented person Uda, this antenna is named as Aggie-Uda antenna. And next one is folded dipole antenna. This name is given after its arrangement. So why? Because it has the two different type of dipoles. One is continuous dipole and second one has cut at its center. So the arrangement is like this. So for this arrangement, here dipole is in the folded manner. So this antenna is called as or named as folded dipole antenna. So third one is helical antenna. So it is named because of its helical geometry consideration for this antenna arrangement. So the helical antenna diagram is like this. It consists of coaxial cable. Later on that helix geometry is present in this. So because of this helix geometry, this antenna is called as the helical antenna. And next fourth one is horn antenna. It is named because of its pattern looks like as a horn. Its arrangement is like as the horn shape. So this is the arrangement of horn antenna. Its pattern is visually like as a horn. For that, this antenna is named as the horn antenna. So these are the just brief introduction about their names of our VHF, UHF and microwave antennas. VHF is very high frequency and UHF is ultra high frequency. Okay, so now we just go ahead with the Aggie-Uda antenna which is invented by Uda and explained in Japanese language, and it is translated into the English by the Aggie, and it got the huge publicity because of his translation, and it is very familiar as Aggie's antenna. Okay, so now this antenna consists of three basic elements. One is driven element, second one is a reflector, and third one name is director. So the number of elements are, it consists of Aggie-Uda antenna purely consists of one driven element, one reflector element, but one or more director elements. Okay, all these are arranged along a straight line. And next one, it is invented by the Aggie and Uda in 1926. Okay, so this is the basic arrangement of Aggie-Uda antenna. It consists of three elements. One is reflector, and the second one is driven element, and the third one is director. Okay, so the practical arrangement or in real-time arrangements, yes, the Aggie-Uda antenna looks like this. This is the reflector element, and this one is driven element, and these are director elements. These are the directors, and its radiation pattern is bidirectional, and it has the major lobe. It is purely directionally from this diagram or from this radiation pattern. Major lobe is very high in one particular direction. For that, it is mentioned as the directional antenna. directional antenna. Why? Because it is mainly concentrated, or it can radiate in the maximum in one particular direction. So for that, this antenna is purely directional antenna. Okay, so now we are move on to the individual element explanation. Okay, so the first name of this element is reflector, that is present back of this entire arrangement. So this is the loss element. Okay, from this diagram we can identify that yes, this is the driven element. This driven element is provided by the some input. Okay, so and second, reflector element is present back of the driven element. And next, one more element, director element, is present in front of the driven element. Okay, so based on these three, okay, we based on this arrangement we can define the individual elements. And reflector element length is 0.55 lambda, and here this is 0.5 lambda. Driven element is 0.5, reflector is 0.55 lambda. Okay, so now we move on to this reflector. Yes, reflector is located at the backside of antenna. It is the extreme back of the arrangement. And next, it is slightly longer than the driven element. Yes, by clearly observing, yes, it is somewhat higher than the driven element. Are you get my point or not? Okay, so guys, here the length of the reflector is somewhat higher than the driven element. How much it is higher than? It is greater than the 5%. So the length of the reflector is 5% greater than the length of the driven element. Okay, so and its length is 0.55 lambda from the diagram. And what is its importance? Radio reflects radio waves towards the front direction. So its main intention is to reflect all the radiations in the forward direction only. Okay, so and next one, what about its practical length? It is my practical length in terms of feet, that is given as 500 divided by frequency. That frequency should be considered in terms of megahertz. So in that condition we can get the its length in terms of the feet. Okay, so 500 by frequency in megahertz feet. Okay, next, spacing between the elements. So how much space we can provide in between the reflector and driven element? So in the diagram it is 0.25 he mentioned. As we can consider the 0.1 lambda to 0.25 lambda, but we prefer the 0.1 lambda or 1.5 lambda for the arrangement. Okay, so guys, now I conclude this reflector definition. So first point is reflector is present back of the aguda element, aguda antenna. So this is the back of the element, and its length is 0.55 lambda, and it is 5% greater than the driven element. Okay, and its main intention is to transmit the radiation in forward direction. Okay, so now move on to the driven element. What is this driven element? So simply driven is for it is driven by the some input. Okay, for that this element is known as the driven element. How could we define this driven element? The element which is provided by the input, or the element which is driven by the input, that is called as the driven element. And it is also known as active element. Why? Because it is the source for the radiations, it is the origin for the radiations. All the radiations are generated from this driven element only. Okay, so now this is the active element, and it is provided by the some input, okay, are driven by the input. And next, it is the responsible for transmitting or receiving of the signal. Okay, so which type of elements are used for these driven elements? Yes, mostly it is half wave dipole. Okay, so its length is equals to the half of the wavelength. L is equals to lambda by 2 or 0.5 lambda. Okay, now so its length is 0.5 lambda. For that, yes, it is half wave dipole, and its practical length is 475 by, its practical length is 475 by frequency in megahertz feet. So 475 frequency should considered in terms of megahertz. So 475 by frequency in megahertz. Okay, that is in terms of feet we can get. And next third element is director element. Okay, so totally we have the three elements. Back of the element is, okay, so like this we can consider this is the reflector element. Back of the element, its length is high compared to the driven element. Its length is 0.55 lambda, and the next element is driven element. Its length is 0.5 lambda, and next third one is director element. Yes, its length is 0.45 lambda. 0.45 lambda. That means that it is 5% less than the driven element. Reflector is 5% greater than the driven element. Director is 5% less than the driven element. Okay, and its practical length is 400 by 455 by 455 by frequency in megahertz, and that is in terms of feet. Okay, and what about the spacing between the driven element and the director element? Yes, that is 0.11 lambda to 0.25 lambda. Okay, next, what is its importance? Yes, it helps the signal in one direction. So the main intention of the director element is to forward the information in desired direction or in the forward direction. And next, it is shorter than the driven element. Okay, so by clearly observing these three elements definitions, okay, so simply I considered the half wave dipole or lambda by 2 element. It is provided by the input. That element is known as the driven element. Its length is 0.5 lambda. And next, the element which is present back of the driven element is known as the reflector, and its length is 5% greater than the driven element, as its length is 0.55 lambda. And next, director element, the element which is in front of the driven element is known as the director element, and its length is 5% less than the driven element. So for that, its length is 0.45 lambda. Okay, so the importance of reflector is to transmit or radiations in the forward direction. That means that it doesn't allows the radiations in the back of that one. And director element is also focused in the forward direction. Okay, so because of all these conditions, we can get the major lobe in only one particular direction. So for that, this antenna is called as the directional antenna, purely directional antenna. Okay, so the direction is altered, definitely we can get the distortion. Okay, and next, coming to the direction of radiations in which manner. Okay, so the radiations are to be propagated, yes, from the reflector to the driven element, and the driven element to the director element, and director from this director element, yes, that is to be radiated in our desired direction. So the maximum radiation occurs toward the director side only. So from that, yes, we can get the major lobe in this direction. Okay, so the side lobe, minor lobes are occurred due to the some radiations in undesired directions. Where it is useful, acute antenna applications are, it is mainly used in the television reception antennas. Okay, TV aspects, television aspects, we can use these particular antenna because of its purely directional properties. Now we are changed to the or advanced to the dish antennas. Okay, initially in olden days we can use we depends on these acute antennas. And next, armature radio communications and radar systems and satellite applications, communication skills links, we can use these type of acute antennas. Okay, so this is about acute antenna. In our next class, we go ahead with the folded dipole antenna and its derivation of input impedance. Thank you. I hope you all understand very well about this I give it antenna. Thank you.